We are going to look at section 2.1, voltage and current sources. Okay, so there are two kinds of sources, voltage and current sources. And even within these two sources, we have two types. There is dependent and independent. Okay, but what do I mean by an electrical source in the first place? If you think about it, an electrical source, it can be a voltage source or a current source. It has the capability of converting some form of non-electrical energy into an electrical form. So that is what a source does. Okay, an example is a battery that converts chemical energy into electrical energy. Now, dynamo is another example that converts mechanical energy into electrical energy. Okay, so that's about current and voltage sources in general. Let me quickly give you the symbols for voltage and current sources here. So, ideal voltage source. Okay, so let me start off with the symbol for ideal voltage source that we will be using throughout this course. So when you see this plus and minus sign, a symbol that shows a voltage source, often shown with a letter V. Okay, so ideal voltage source is one that provides a constant voltage across the terminals. Across the terminals, voltage across the terminals is constant. You can almost think of it as the voltage is set by this device in this circuit. Okay. On the other hand, if you look at the current, that is not constant, that is not defined. If you think about the current that is flowing through this device, that's current I, that is set by the load. Okay, the external connection connected to the terminals of this constant ideal voltage source, that sets the current. However, independent of what the external circuit is, the voltage in this guy across the terminals is set. Okay, and then if you think about the IV characteristics of this voltage source, ideal voltage source, plotting voltage on the x-axis and the current on the y-axis, you will see that, let me use a green color here, you will see that the voltage does not change even when the current is changing over a wide range. Obviously, it's impossible, almost impossible to find a real circuit that behaves exactly like this, but the idealized behavior is such that the voltage does not change even when the current is fluctuating or changing drastically. Okay? So that's the IV, I versus V versus I. Current as a function of voltage. So that's ideal voltage source. Similarly, there's also the notion of ideal current source. Now the symbol for this shows an arrow. Okay, an arrow pointing for a current source. Okay, an ideal current source. Look something. Again, very similar to the voltage source, the ideal current source also has a variable set. Okay, the current is set by this this device. Okay, and then provides constant current. Okay, so in other words, independent of what kind of load is connected across the terminals, the current through all of that load I is constant. So this ideal current source provides a constant current through the load. The voltage might vary, okay? The voltage might vary, but the current will still be the same. So if you are to look at the IV characteristics of this guy, voltage on the x-axis and the current on the y-axis, you will see that the current is going to be constant. Let me highlight this a little bit more, like so. So the current is going to be constant even though the terminal voltages, the voltages across this guy, okay, plus the voltage across this guy, even though it is varying over a wide range, okay, that's an ideal current source, provides constant current, okay, and we are going to see this in problems and analysis henceforth. In the next video, we are going to look at dependent current and voltage sources. So the two symbols I have shown so far are for independent voltage and current sources. So this is an independent voltage source, and here is an independent current source.